Good morning, sir. Myself Vasundhara from Departments of Computer Science and Engineering at Srinivas Ramanujan Institute of Technology. Today I will be presenting on the topic Emerging Careers in Quantum Roles, Skill Sets and Preparation Pathways. Quantum technology is one of the most revolutionary fields shaping the future of science and technology. It combines the principles of quantum mechanics with computing, communication and sensing to achieve things that classical systems cannot. In this presentation, I will be explain the different career paths emerging in different domains, the skill needed, and how students like us can prepare for these opportunities. Outline. Here is the outline of my presentation. Introduction to quantum careers. Roles such as quantum research, scientist, software developer, hardware engineering, algorithm specialist, and cryptography. Industries and business opportunities quantum. Essential skill sets required. Educational pathways to enter this field, professional development and certification, preparation for quantum career, and finally the conclusion and outlook. Quantum technologies is evolutioning rapidly and opening up new professional opportunities in various sectors. It's not just limited to physics, it now connects computer science, engineering, and mathematics as well. Governments and tech companies like IBM, Google, Microsoft, and Intel are heavily investing in the fields to build the next generation of quantum computers and communication systems. Because of this, there is a growing demand for experts who understands quantum theory and can apply it to solve real-world problems. So a career in quantum does not mean you only work for research lab. You can contribute to software, hardware, business, and even cyber security roles. Let's now explore these career paths one by one. First one, the first and most the first and most traditional role is that of quantum research scientist. These scientists develop and test now new quantum technology arguments, materials and devices. They work on discovering bettering quantum processes, superconducting materials of photonic system. To become a quantum researcher, one needed a strong background in physics and mathematics and usually as a PhD is required. They often work in universities, government laboratories and provide research institutions. Their goal is to push the boundaries of what possible with quantum mechanics, like increasing qubit scalability and developing new error correction techniques. This is a role suited for those who enjoy experiment and deep theoretical understanding. Next, we have quantum software developer. While quantum hardware is being developed, we need software to control it like and make it useful. Quantum software developers design, write algorithms and programs. They can run on quantum computers. They use programming languages such as Python and frameworks like QUISC, C or Q slash. They also need a group grasp of good quantum mechanics to understand how qubits behave and how quantum algorithms differ from classical ones. This role is perfect for students with a background in computer science and an interest in learning quantum computing physics. It is the one of the most accessible entry point into a quantum industries right now. Next one is a quantum hardware engineering. Focuses on the physical components of quantum systems. They work on building and testing computing processes, superconducting circuits, and cryogenic systems. This role demands expertise in electronics, nanotechnologies, material science, and cryogenics because quantum computers often operate at temperature close to absolute zero. Hardware engineering collaborates with physicists and technicians to ensure qubits perform reliably and can be scaled up. A bachelor's or master's degree in electronics, mechanical or materials engineering can be good start. Without these engineering quantum computers would just remain theoretical concepts that turn scientific ideas into working mechanisms. Another exciting role in the quantum algorithm specialist. These professional focuses on designing algorithms that makes use of quantum properties like superposition and entanglement to solve complex problems efficiently. They work on the tasks like optimization, cryptography, molecular simulations, or artificial intelligence. This requires a deep understanding of linear algebra, probability theory, and computational complexities. Quantum algorithm specialist often collaborates with physicists and software engineers to create new approaches that can outperform classical algorithms. For example, they might work on improving quantum versions of search or factoring algorithm. This career is great for those who enjoy mathematics or theoretical problem solving. A quantum cryptography. A quantum cryptography works on securing data using quantum principles. They develop encryption and communication systems that can't be hacked using classical computing methods. One key area that work in the quantum key distribution, a method of sharing encryption keys security using photons. If someone tries to intercept the key, the quantum state changes, alternating both parties to the instruction. Quantum cryptography usually comes from computing science, cybersecurity, or quantum information background. This role is becoming highly important as computer could one day break current encryption system. Therefore, protecting sensitive data using quantum techniques is a top priority for government and communities. Quantum technology is not limited to research labs, it's also moving into the business world. There is a industry roles like product management, consulting, marketing and strategic planning for quantum products. Professionals in these areas bridge the gap between science and business. They need to understand both technical aspects of quantum computing and market trends, such as how quantum solutions can impact industries like finance, healthcare, and logistics. Essential skills for quantum career. Now let's talk about the skills that are important in quantum careers. First, a strong foundation in quantum mechanics and linear algebra is essential as these are core principles behind quantum computing. Second, programming skills, especially in languages like Python, are very valuable. Third, problem solving, analytical thinking, and teamwork are equally important because most quantum projects involves interdisciplinary collaboration. Educational pathways to enter quantum fields. To enter the quantum fields, students can start by pursuing undergraduate degree in physics, computer science or engineering. During your studies, try to take courses related to quantum mechanics, electronics and programming. After that, you can move into specialized masters or PhD programs in quantum science or quantum engineering. It's also important to gain practical experience by joining research projects, internships, or online quantum labs. Professional development and certification. Professional growth does not stop with a degree. You can attend workshop, conference and webinars on quantum technologies to stay updated. Several online platforms offer certifications in quantum computing and quantum programming. For example, IBM, Microsoft and EDX. Joining organizations like IEEE Quantum or APS Quantum also helps you network with experts and stay informed about the latest trends. Preparing for a quantum careers. It's important to build both academic knowledge and practical experience. Start with the basics of physics and computing and gradually explore advanced topics through online platforms. Participate in hackathons, workshops and research projects to gain hands-on skills. Develop cross-disciplinary knowledge, for example, combining computer science with quantum physics or engineering. Mostly important stays crucial and adaptable because these fields is changing fast and new discovery happens every year. To conclude, the quantum industry is growing rapidly and offers a wide range of career paths from researchers and software development to cryptography and business strategies. Success in these fields requires a balance of technical expertise, creativity, and lifelong learning. As quantum technology continue to evolve, they will transform industries and create opportunities we can't even imagine today. So if we start preparing now by learning the right skills and exploring the field, we can become part of the next major technologies. Thank you.